Hey Algebra 2, thank you for being flexible with me today on the day that I am gone. If you have any questions today during the video or before tomorrow before I get back, please don't hesitate to email me or send me a quick text via reminder. I will do my best to get back to you if I can. Otherwise, we do have a work day tomorrow on the 3.3 worksheet that I'm going to be giving out. So if you don't finish the homework before tomorrow, totally okay. We will have time to work on it and get some of those questions answered. So let's jump right in. 3.3, graphing systems and inequalities. Hopefully by this point we are more comfortable with graphing our lines, a little bit with the absolute values. Because if we're not strong on those separately, graphing them with systems is going to be pretty challenging. But to solve a system of inequalities is really only two steps or two ideas. We're going to graph the inequalities in the same coordinate plane, and then the solution set is just the intersection of the graphs. Well, what does this mean? Well, we have this picture, this horribly colored in picture, but it's this middle section, if you couldn't tell, that is colored in. And the solution set is not just one point anymore, because it's not an equality, it's an inequality, which means we have an entire section that is our solution set. So how do we go about figuring out which set or which set of systems here is the solution for this graph? Well, we could sit here and actually solve each of these for y, but it would take quite a while. The first thing I see is I see that the origin is in my solution set. It's in the colored in area. So I know that 0, 0 has to work for both of my equations in order for it to be part of the solution set. So I'm going to plug in 0, 0 into these solutions, or I'm sorry, not into these solutions, into these equations and see what works. So if I plug 0, 0 into my A, I get 0 minus 0 is less than or equal to negative 2. Well, right away I can tell you 0 is not less than negative 2, so I cannot even go on with A. A is not going to work. If I go over here to B, I get 0 minus 0 is greater than negative 2. Okay, that one works. 0 minus 0 is less than 2. Okay, so B is still in the running. We're okay with both of those. When I come over here to C, I get 0 plus 0 is less than negative 2. Already another one I'm seeing as a problem, not going to work. What about D? Well, I get 0 minus 0 is greater than negative 2. That one's good. And then we get x minus y, which is 0 minus 0 is less than 2. So B and D are still in the running. Well, how do we narrow it down from here? This is the point where I would say, let's actually figure out what these all are as y equals, and then graph them and see what happens. So I'm going to do that down here, and I'm going to type it out. So I move the x to the other side in that first one, divide everything by negative 1. I'm actually not going to be able to do the greater than or equal to, so I'll have to write that. Just put some space there. But it'll be y, and then x, and then when we divide it, it's going to be plus 2. Let me grab my marker here. And I did, when I simplified this, divided by a negative, so I'm going to have to flip that sign and keep the or greater or equal to sign underneath it. So I've got one of my equations there. When I simplify the other one, I get y sine x minus 2, and then I'm going to have to jump that sign in there. So this is just the simplified y equals version of b. And let's just graph that and see what happens. This one is going to be a solid line, so I'm going to grab a solid line. It goes through at the point 2. It's got a slope of up 1 over 1. So I can already tell you that this line is going to work. And then it says y is less than, so I always like to write myself a little reminder that I'm going down. And then I have to graph my second line here. That one, because it doesn't have the or equal to underneath, is going to be dotted or dashed, whichever you prefer. It's going to be a dash line. I'm not going to put arrows on it. That one starts at -2. I don't know where my line just went. I had it and then it disappeared. There you go. It goes -2 and then has that same slope of up 1 over 1. And I'm already seeing that B so far is working. Let's double check just to make sure. If Y is greater than the line I just graphed, that means it's going to be up. So I care only about where both arrows are pointing, which is in this middle section. So do these two lines work? Yes. Everything is set up. So I don't even have to check D because I already know that B works. The fastest way to solve stuff like this is narrow it down to 2 and then, graph it. See if one works. If it doesn't, it's automatically going to have to be the other one. How would you draw an absolute value inequality containing only one variable on the coordinate plane? Consider the following. Well, we know inequalities are basically just x equals the positive number outside of the inequality and x equals the negative number outside that inequality. Those are our only two solutions. This inequality tells me since there's no line underneath that it's going to be dashed. So I can graph this without issue because I know what x equals 3 and x equals -3 look like. They are just two lines at x equals -3 and another dashed line at x equals 3. And the inequality also tells me that the absolute value of x is going to be less than 3. So it's going to be everything inside of this. Even if I put in -3, it's still just going to be less than. So it's shading everything in here. And there's not a great way to do this online, but I'll just put some dash marks through so you can see where you should be shading. So that's an inequality with an absolute value, at least in that form. If we jump over here, this one's a little trickier, but we see that this is a more is or type. Remember that little phrase I threw at you at the beginning of the year? Because the absolute value is greater than the number, it's a more is or, so our arrows are going to go out. So I know, like I said, that what's in here can either be the positive version, so y plus 1 equals 5, or y plus 1 could be the negative version, the negative number outside. And these I can graph. We're okay with these. You simplify them to y equals 4 and y equals -4 and graph. This one does have that little line underneath, so it's going to be a solid line. I'm going to go up here to 4, down to -4, and it's a more is or, which means it's going to be outside. They're not going to connect. That would be an and, because it would need to be between this line and this line. So more is or tells me it's going to be up here, or it's going to be down here. It's not going to be in between. I know this is awful shading, but bear with me on my computer. So graphing inequalities here, all we're doing is connecting what we know about graphing absolute values with our inequalities. However, now we're going to take that and we're going to solve these systems by graphing. So let's go. What is y equal 2x minus 1? What does that graph look like? All right. I'm going to put that one, let's see if I can change the color here. All right, so I'm going to put that in blue, and then I'm going to graph it in blue so you can also see it. All right, this line goes through the y-axis at -1, has a slope of +2, and you can shade everything if you want. So this one is, once I get to this point, I say y is less than or equal to, so I could shade everything that worked. In this case, if I plug in 0, 0, I get 0 is less than or equal to -1, which is not the case, so I'd shade this stuff. I think that it gets a little bit messy, personally, so I just draw arrows. But again, if you want to shade stuff and then see where all the shading overlaps, that is totally acceptable as well. Here we go again. This one, it's already in black, so I'll just graph it in black. Goes through at +2, has a slope of up 1/3. Let's extend that line. Okay. And then my arrows, for me, I know y is greater than that, so I'm going up here. I'm going up. And the place where those arrows are going to meet, this only catches the blue line stuff. This only catches the black line stuff because the arrow's pointing over here. This doesn't catch anything, but the cross section where they meet, where the arrows are pointing at each other, is going to be where my solution set actually lies. So if you're going to fully shade at the end here, shade everything in between those two lines, because that's where the solution set actually is. And I will go back because I did make a mistake, and I'm seeing it here now, that this line was actually supposed to be, did anyone catch me on my mistake? It's supposed to be dashed, because there's no little line underneath that inequality sign. It doesn't change where I shaded, doesn't change how I graphed or anything like that. It just changes the line itself. So there's that one. This is just putting together a lot of what you've already seen, so I hope it wasn't a lot of new information, but I am now giving you time to work on homework 3.3. Again, if you have questions or this was just a little too much, we will have work time tomorrow.